Hello everyone and welcome to another short video on our own devices. I'm Jean Messier and today we are having a look at a fascinating piece of aircraft maintenance equipment. This is a Martin Decker airplane type tension meter, and as the name suggests, this is designed to measure the tension of steel cables, specifically aircraft control cables. Now, you know me, I love incredibly obscure and specific tools, so let's have a closer look at this and let me show you how it works. This device was manufactured by the Martin Decker Corporation of Long Beach, California, which was formed in 1928 by Elmer Decker and W.B. Frosty Martin from what was formerly the Loomis Oil Well Control Company. The company produced a variety of tools for the petroleum and other industries until 1990, when it was purchased by Houston-based firm National Oil Well Varco, or NOV Incorporated, and merged with the Technical Oil Tool Corporation, or TOTCO, to form MD TOTCO. TOTCO is best known for its eponymous drift recorders, which are used to determine the drift or deviation of a borehole from the vertical. Interestingly, my father worked as an exploratory geologist in the 70s and 80s and used many such devices, and I've even spotted a few examples up at the Mining Museum in Snow Lake, Manitoba. They actually have a whole bunch of fascinating artifacts, so hopefully one day I will go up there and cover a few of them for this channel. Anyway, this tension meter appears to be based on patents filed by one Otto Berger Goldman in 1927 and 1928 and assigned to the Martin Decker Corporation. According to the advertising material that came with this unit, it was specifically designed to measure the tension of control cables in the Douglas DC-4 airliner and transport aircraft, which first flew in 1942 and was used all the way into the 1990s. More specifically, being a Royal Canadian Air Force marked unit, this particular example would have been used on the Canadair North Star, the Canadian variant of the DC-4 introduced in 1946, which substituted Rolls-Royce Merlin V12 engines for the original Pratt & Whitney Twin Wasp 14-cylinder radials. Setting and maintaining proper control cable tension was vital to maintaining predictable and safe handling characteristics, since if the cables were too slack, the controls might be sluggish and unresponsive, whereas if they were too tight, it might actually damage sections of the control system. Furthermore, the cables in the aircraft structure would have different coefficients of thermal expansion. Thus, as the aircraft gained or lost altitude, the tension of the cables would change, and this had to be properly compensated for. Right, so if we pull the unit out of its box, we can see that at one end we have a pair of hooks for holding the cable being measured and a retractable piston for applying transverse force to said cable. While at the other end, we have a readout dial calibrated in pounds force and a threaded housing that can be rotated to extend or retract the piston and vary the force applied to the cable. If we unthread this, we can see that the gauge itself is a sealed unit. The piston presses on a flexible diaphragm which transfers pressure via hydraulic fluid to the gauge. According to the instruction sheet on the inside of the box, to use the tension meter you must first calibrate it, which you do by using a calibration bar, which unfortunately is missing from this example. However, for demonstration purposes, I will substitute this metal rod. You place the bar in the hooks, then thread in the housing, extending the piston until the dial reads 0. Then, without touching anything, you slide out the bar and turn this knob in the center of the dial to set this red reference needle to the 0 position, outlined in red on the bezel. You then hook the device over the cable to be measured, and depending on the thickness of the cable, turn the housing by a certain angle given in fractions of a complete turn as marked on the bezel. These values are stamped into the brass calibration plate on the side of the housing. For example, for a 3/32 of an inch cable, you turn the housing 4 and 23/32 times. For a 1/8 inch cable, 3 and 15/16 times, and so on. And if the unit is properly calibrated, then the dial should display the longitudinal tension of the cable, which an aircraft maintenance engineer can then adjust using turnbuckles. Now, for the curious, tension and transverse deflection are related by the following formula: T equals PL over 4D, where P is the transverse load, L is the length of the cable segment, in this case the distance between the two hooks, and D is the transverse deflection. Anyway, that's all I have for you today. Thank you so much for watching, and a huge shout out to Gord Crossley over at 17 Wing Heritage for allowing me to borrow this unit and cover it for you in this video. I'll see you next time in another video where we'll look at yet more fascinating tools and other devices just like this one. Until then, I'm Jean Messier from Our Own Devices. Have a great day.